Hello there, Would-Be Ben here with another weekend project. This is our hot tub. It's quite old now, and unfortunately I think one of the motors has a bearing that's going out. So the project for this weekend will be to see if we can pull the motor out and replace the bearing. I have a feeling it's going to take a little bit more than a weekend to fix this. Let's start by removing the front panel so that we can access the controller and the pumps. How do we know which jet is bad? Well, we listen and hear the bearings. This is the sound of pump number 1, which is our water recirculating, and jet pump for jets on this side of the hot tub. That's the low speed sound. And that's the high speed sound. Now we're going to turn on the second jet. Oh, that sounds horrible. It really just sounds like metal grating on metal. So we know that pump number 2 is the culprit here. First, we'll make sure we shut off the circuit breaker to the hot tub. So right here. Okay, we've turned off the power at the circuit breaker, and we're going to open up the control box to access the wiring to the pump. Inside the cover is a wiring diagram, and on the wiring diagram we see here that pump number 1 plugs in here on jumper 23. Pump number 2, which is designated as blower / pump 2, is plugged into jumper J17. You can also just trace the wire from the pump and follow it to see where it plugs into the board here. Alright, we're going to take this connector off of J17 here. You need to pinch the prongs on the top and the bottom first, and then pull straight out. These prongs here release it. And I've used a Sharpie marker to mark this as jumper J17, so I'll know where to plug it back in. There's a wire keeper here that we'll need to release to get this wire out of the control box. Wire keeper, wire, and now the pump wiring is free. We'll put all this back together temporarily so we don't lose any parts. I'm hoping we can get this pump out without having to drain the entire hot tub. There are 2 gate valves that can be used to isolate this pump. One here on the one end of the pump and one down here. There's a clip on each one of these shafts, so I'll pull these clips off, and then I'll close the gate valve by pushing it like that. Guess I have to close this one first because it's kind of in the way. There we go. Yeah, that one's closed. And there's a lock here. Alright, it's a little tough, but there's a little lock on the pin here that you have to engage in the groove and then twist it around to lock that gate closed. Same with the lower one too. The base holding this motor and pump in place appears to be held in place by 3 Phillips head screws that are screwed into the bottom of this hot tub frame, so I'm going to see if I can get those loose somehow. These motors are probably installed before all the other components, so very frequently there's stuff that's in the way. It makes it difficult to access, so sometimes using a very long extender on your nut driver might help, and also sometimes using a short stubby screwdriver may help with access. Well, that's a 1. That's 2. And 3. I didn't say it was going to be easy. There's a ground wire on the top of the motor that's going to also have to be removed to allow us to take the motor out. So there's that ground wire. This appears to be the outlet for the air bubble generator here. And there's an accessory hose that we're going to need to disconnect here. This one's held in place by some twisted wire. I imagine in most other instances there will be a hose clamp or zip tie holding that in place. Ooh, that actually has water coming out of it. So I'll have to find something to plug that up. Okay, I think I found just the thing. I'm going to use the end of the Sharpie marker. And that fits just about right to plug that up. There, I'm going to use a band wrench here around the coupler. Yeah, that wasn't too hard actually. There's going to be some water draining out of here. We'll see how well the gate valve works though. Yep, that's the way to loosen it. Alright, so we now have this pump disconnected. And now we just have to wriggle it out of this tight location here so we can work on it. So this turns out to be a 6 horsepower Aquastorm pump. It is equipped with a Marathon electric motor and a wet pump head. Well, let's start taking this thing apart. We've got a bunch of screws holding the end of the pump in place, so we'll just start by taking these out. These are actually machine bolts. Alright, let's see about separating this from the body of the pump here. Alright, so we got that out. There is a bearing flange here, or a seal. The shoulder is out. They're facing away from the rotor here. We'll have to remember when we reassemble that. It looks like we're going to need a large Allen wrench to loosen this up in the center. Okay, I found that a 3/8 inch Allen wrench does fit into that, but when I turn this, the motor shaft also turns, so we need to find a way to fix the motor shaft and prevent it from turning so we can loosen this. There's a plastic cap on the motor end here, and we just need to pry this cap off. And inside, you can see that there's a slot in the end of the drive shaft of the electric motor. So we'll need to take a large flat-bladed screwdriver to hold the drive shaft in place while we loosen the other end. This will probably require a 2-person operation. All right, let's give this a go, huh? You ready on that end?
Yep.
All right. I think you're off there.
Okay.
You might need a little more torque here.
Okay.
All right, let's go to plan B. Well, plan B involved removing the rear motor covers so that a large vice grip could be applied directly to the drive shaft. Applying enough torque to break the threads loose stripped out the hexagonal hole in the front of the impeller and ultimately broke the front of the impeller off. Well, for the sake of honesty, this is what our impeller ended up looking like. Sometimes it is difficult to get these off without damaging things, but ultimately I learned that this is threaded directly onto the motor shaft with a conventional thread. It's not reverse threaded. So to remove it, you have to turn it counterclockwise. So I'll be ordering a new impeller. Hopefully you'll be able to avoid that by turning this counterclockwise to get it off. Now inside here we have our seal, and looks like there is a little bit of a crack here, and we've got the motor shaft directly threaded on here. To remove the wet end from the electric motor, we need to spin this around and remove these 4 long bolts, which actually run all the way through the motor case, all the way through the motor case to the base of the pump. They're very long bolts. And there we go. The wet head or the pump has now been completely removed from the motor. And now we'll plug this in and see how it sounds with the wet head removed. Okay, here we have the motor with the wet head or the pump end removed. I've got to plug back into the power just to see what it sounds like by itself. So it sure sounds like that bearing on this end of the motor is bad. To access the front bearing, we just need to pry the front motor cover off using a stiff spatula and a few taps of a hammer. Okay, now that we've got the front of the motor off, we can actually pull this stratter out of the coils here. So we can see the bearing on the back here and the bearing on the front here. So the noise is all coming from the front bearing here. So now I've got to work on pulling this bearing off the axle here. I'm going to try to use this gear puller to pull this bearing off. Hopefully we can coax it off the shaft this way. Looks like it's coming. There it goes. Okay, we have our bearing removed. Now we just have to find out what kind of bearing this is and order a replacement. Looks like there's some lettering on the inside here. This was a 6203-RZ ball bearing. I was able to locate one and purchase it through eBay for $7 including shipping. We've got the old bearing off. We've ordered a new bearing which just arrived. It's just a matter of replacing the old one with the new one. We can see that the shaft has got a fair bit of corrosion on it here. This may be the last time we can rebuild this particular motor, but we'll see what kind of mileage we get out of it. It just has to go right over the top. I'm just going to use a deep socket wrench here to tap this bearing onto the shaft here. Make sure we've got it on there all the way. And we can see now how that fits there. So we're back in position. Now we just have to put the cover back on. And we may have to tap this a little bit to get the bearing seated on both ends of the motor here. Use another deep socket here. All right. So that's got both of the bearings reseated, and we can turn the shaft very easily with no noise. Let's turn our attention back to the wet end of this, so the water pump. Since I damaged the impeller trying to remove the wet end from the pump, I needed to look up a replacement. Turns out that this particular motor here from Aquastorm Pumps, the wet end here is not available and you can't find the parts for it. So I needed to find a replacement wet head that will bolt onto the same pump as a replacement. One thing that I've learned is that this little sticker on the motor here, which says 6 horsepower, really doesn't mean anything. What you have to do when you're looking for a replacement is look on the actual motor sticker here and look at the amperage rating of the motor here. This is 12 amps. And there are several sources where you can look on the internet to find replacement wet ends. And that 12 amp rating translates to 3 horsepower, not 6 horsepower. Another clue as to the actual horsepower rating on the wet end here is if we look at the hub, we see the number 3 stamped in the center of the hub, which indicates that this is actually a 3 horsepower rated impeller. Okay, I was able to order a replacement wet head. This is a 3 horsepower wet head, and more importantly, the dimensions are pretty close to the original, especially the dimensions of these threads here on the input and on the output side here. We should be able to attach this new wet end to the motor simply by threading this back over the shaft. We're going to use a flat screwdriver, insert it in the end of the shaft here, and turn the shaft. I'm turning the shaft clockwise. And I'm going to reach inside with my finger here and just hold the impeller to keep it from rotating as I turn. And that feels like it's getting tight now. It will reinsert these long bolts that run through the motor here. Line those up with these legs. So our replacement wet head has been mounted back on the rebuilt motor. Our original wet end had a 3/8 inch barb accessory output here. On the new pump there's actually a drain plug, so we're going to have to exchange that for a 3/8 inch barbed connector. This drain plug measures 11/16, so we'll use a there is a O-ring visible here, backing some, looks like 3/8 inch pipe thread there. We ordered the pump along with a 3/8 inch hose barb. Just matching the thread here. That looks like a reasonable fit. And we're going to use some silicone to seal these threads. And this is actual silicone sealant, so this will sit up semi-permanently. Here's the O-ring on there. Just want to make sure I don't cross thread this thing. Alright, looks like that O-ring should be seated down in there. This looks like it's actually sitting pretty flush. This should now be ready to reinstall. Now we have to reverse the removal process to put the rebuilt pump back in. Before I forget, I'm going to have to snap this plastic cap back on the end of the electric motor, which is down here. Unfortunately, it just snaps right on. Okay, so I've got this reattached with the new hose clamp. This was leaking initially, but now it's stopped since I've tightened this clamp. Let's see if these gate valves will open up. We'll look for any leaks. So far that looks good. Let's open up this one. You can hear the water gurgling now. And I don't see any leaks either. And we'll make sure you put these clips back on so that these don't accidentally close. And don't forget to reattach this ground wire here. And we have to re-secure the motor base to the hot tub chassis. And confirming that the power is still off, now we're going to rehook the electrical. Jumper J17. Okay, power's back on. Let's see what the jets sound like. Now this is the jet number 1, which wasn't the one we worked on. Low speed, high speed, and off. And now pump number 2. This is the one we rebuilt that was making such a racket. Oh, that sounds so much better. And the pumps are pumping. So it looks like we have ourselves a successful rebuild of that pump. Well, there you have it. Another project taken care of, checked off the list. Even though I ended up breaking the impeller on my original no-name brand wet end, it turns out that there were no parts available for that particular wet end anymore. So I ended up buying a replacement wet end, Waterways brand, which does have replacement impellers available. The cost of the new wet end was $66 plus tax and shipping. The bearing that we purchased to replace the one on the electric motor was $7, including shipping. A whole new pump would have cost $300. So we did end up saving a little bit of money, and we also saved the old electric motor from going to the dump. So that's a +1 for the planet. Anyways, that's it for this project. If you found this video to be helpful, please subscribe to my channel. Until our next project, bye-bye.